Good morning, good afternoon, and good night. My name is Marlene Warner, and I am from the group 6 Rings. The group consists of Kylese Gums, Onise Pearson, Callie Merrifield, Likayla Christian, and Jonathan Guzma. And today we'll be talking to you about glass evidence.
Greetings, everyone. I'm Callie Merrifield, member of 6 Rings, and I'm here to talk to you about the murder of Gregory Biggs. On October 26, 2001, 25-year-old nursing assistant Shantae Mallard struck 27-year-old Gregory Glenn Biggs, a homeless man with her automobile, in Fort Worth, Texas, United States. This came as a result of her being highly intoxicated. The night before this, she took ecstasy pills and she was at a party drinking and, she was intoxicated. And the force of the crash launched Biggs into the windshield, which was made from laminated glass. As we know from previous lessons, laminated glass is highly durable. It's the windshield, and when it breaks into several glass shards. And in continuation, Mallard then drove home. She drove home from when she crashed into him. She drove home and she parked her car in her garage and left him there. And he later died 1 to 2 days later. It can't be confirmed, but he died 1 or 2 days later as a result of his injuries. Mallard was convicted and sentenced to years imprisonment. She was sentenced to 50 years imprisonment for her role in his death. Thank you. In continuation with the summary of the case, this is a sketch that I made for Shantae's garage. This is where she drove from where she hit him, and she just left him here to die. And we could see that we have the car, the busted window. We have glass shards from the key. We could tell that's glass shards. We have a cabinet, a shelf of cleaning supplies that she had. We have the garage door. And B would be the entrance to the kitchen from the garage. The date of this is February 26, 2002, time 2:25 p.m. Incident, this is a hit and run / murder. We have the dimensions of the room. We have the measurements of that. And yeah, this is my sketch of her garage. Thank you.
Afternoon, today I will be doing the comparing glass submersion method. The 3 liquids that I will be using are oil, water, and the orange glowwood furniture. Then I will be putting the pieces of glass in this first one, which is barely to see, kind of, not really. And then the second, which is water, is also visible. And then a piece of the oil, which is visible. So
good morning or afternoon to whatever time you're seeing this, and today I'll be describing which fracture pattern came first. So the first fracture pattern right here, I'll label this A. Why? Because this is the longest this has the longest radial lines that's stretching out. The radial lines are stretching out further than any one of these. Like even when they meet, it stretches past the radial lines that's meeting with B, or like so on. Second, B, because B is leading towards A. It's the closest one leading to A. So like it stretches to A, the closest. And well, basically the last one is C, because like C radial lines are both leading to B and A. They're both leading to B and A. So that's practically the last one. And like if you ever like out and you see like 3 punctured holes or more, you could just figure out which hole came out, like which hole was there first for fun or something. So I hope you found this helpful and have a good day.
Analyzing glass patterns, you first have to be able to identify the different types of patterns in the glass. The first pattern we have is the radial pattern. The radial pattern is a crack in the glass that extends outward like a spoke wheel from a point at which the glass broke. This right here are my radial patterns, while the concentric pattern is the points in a glass, is the fractures in a glass that forms a rough circle. The difference between a radial pattern and a concentric pattern is that radial fractures are similar to the spokes of a wheel, while concentric fractures are patterns similar to a spider web. You can see how the glass is stretched, which causes stretching in the concentric fractures. Radial fractures occur on the same, not on the same side, but on the opposite side of where the glass was struck. So my glass was struck on this surface that you see here. So the part by the cardboard is where you would see the radial patterns, while the concentric patterns show up on the same side that the glass was struck, which is this surface area right here that you see. In order to tell which glass fracture came first, you have to know exactly where the glass was struck. For example, this piece of glass was struck right here in this middle center point. If I was to break another piece of glass after this glass was struck, let's say the glass broke right here, you would be able to see not only the radial patterns, but the concentric patterns. Now, these two patterns will indicate which glass was broken first. So, if this glass was broken first and this glass was broken second, more than likely this glass would try to connect with this glass, similar to how I am connecting these pieces of glass right now, with the concentric fractures still forming their spiderweb shape, but these radial fractures reaching out to try and connect with this initial piece of broken glass. A bullet at a high velocity produces a hole in a glass where the exit side is wider than the entry side. For example, this will be my exit hole, and this will be my entry hole. My exit will be larger than the entrance hole. Now, in order to determine what direction the force of the glass broke at, you will have to find the sharply tapered pieces nearest to the hole, which are labeled the radial breakage pieces. You will most likely find them around this area of the glass, which you can see right here. You will most likely find them at this area of the glass, which you could see right here. Now, to tell what type of glass you have, normally tempered glass have completely smooth edges due to the extra processing it goes through, while other glasses typically have stuffed or rigid edges. If the edges of a glass are exposed, carefully run your fingers along them to try and determine what type of glass you have.
Broken glass found at a crime scene location is a significant piece of scientific proof. The types of glass that are found are usually from a window, light, headlights, or jugs. Each have exceptional properties that can be used to solve a case. Glass can be individual evidence when there are a fitting of two glass fragments. Glass is usually class evidence because without two fitting glass fragments, glass can be identified but cannot be linked to a specific object. Glass can be trace evidence by tracking the unique characteristics such as color, optical properties, and density, which can determine the type of glass. You have made it to the end of the video. Thank you for watching, and I hope you keep a piece of information in your head for future references.